Good evening. In this video, we are going to explore proposition 2 from book 1. So similar as the previous one, we will have to use these kinds of definitions, postulates, and common notions and a previously proved proposition. So let's start this proposition. Proposition 2 says that if we have a specific point A and a given finite straight line BC, we are able to construct another straight line with the extremity A whose length is equal to the given straight line BC. Okay, so let's start this proposition. Please have a look at postulate 1. We can, given two specific points, we can construct a straight line. So let us at first connecting AB and construct this straight line. And then please recall proposition 1 from book 1. Given a straight line, we can construct an equilateral triangle on it. So we will just skip the steps in proposition 1 and directly draw an equilateral triangle here. And let's assume it is triangle ABD. And then please recall postulate 2. Given a straight line, we can produce it to infinity. So here we will produce straight line DB and DA. DB and DA. To A, B, C, E, and F. Produce it more. E and F respectively. Okay, then the next step, we are able to construct or describe a circle with a given point and radius because of postulate 3, right? So let us describe the first circle. We use B as a center and BC as a radius to construct a circle. Great. So let's assume it intercepts with DE and DF at G and H respectively. Okay, so now we have circle BGH. And then similarly, still postulate 3, we can construct another circle. The center would be D and the radius would be DH. Okay, D and H. Great. And let's assume this circle is A, B, C, D, F, G, H, I. Okay, let's assume this point is I. So we have another circle, I, H, and let's assume a random point on this circle on the circumference is J. So we have a circle H, I, J. And let's prove we have constructed the straight line. Okay, so please recall the definition of a circle. In a circle, all of the radius are equal to each other. So we call this circle, we have BH is equal to BC. Okay, so BH equal to BC, right? And in this circle, we have in circle HIJ, we have DI is equal to DH. DH equals to DI. All of them are based on definition 15. And recall definition 20, it defines what an equilateral triangle is. So we have, this is an equilateral triangle, so we have DA is equal to DB. DA is equal to DB. Great. And please recall common notion 3. If we subtract the same thing from two equals, the results are equal. Okay? So let's make the subtraction. DH minus DB is equal to DI minus DA. Why? Because DH and DI are equal and DB and DA are equal, okay? Which means DH minus DB, BH is equal to DAI DHA. Okay, and in the next step, please recall common notion 1. We already have BH equals to BC, so we combine these two equations together. It tells us BH equals to BC and BH equals to AI. It tells us BC is equal to AI. So AI is a straight line whose extremity is A and the length is equal to the given straight line BC here. They are equal. So I think this proved that our construction is correct. And this is the end of the proof. So I think it is the end of proposition 2 from book 1, and in the next video we are going to talk about proposition 3. Thanks for watching. Have a good day.